So now we've determined in this example problem what our forecast is going to be for day 22 and how much measure of error deviation that we have within our model that's using an alpha of 0.20, a weighting if you will. And we are going to use this as a predictor, but is this the best model? Well, before I get into determining if this is the best model, I do want to show you something really fast. We went through and painstakingly used this formula that was provided in Excel formulas over in this table to determine what our y-hats, our predicted value, was for each one of these days using that exponential model with an alpha of 20 and our assumption that the predicted value on day 1 would be equal to the actual observed value on day 1. And we had to type in some numbers with fill handle. It wasn't that bad, but to let you be honest with you, Excel can actually do this for you. If I go to the data analysis tool pack, Excel has in here a function called exponential smoothing. And if you go and grab exponential smoothing and you hit OK, it's going to ask you for your input range. And your input range, and I'm going to use the header, is your actual observed value of the response variable that you're going to use. And then you need your dampening factor. And what the dampening factor is it's that part of our formula that we have right here that was the complement of our alpha. So since we use an alpha of 0.20 instead of in the problem, the complement of that would be 0.80. That is our dampening factor. I did include the top row, so I want to put labels on. And for my output range, I'm going to put it right underneath our y-hat. And that is C24 in this case, and I'm going to hit OK. And as you can see from the returns I get, do they look reasonably familiar? They absolutely do. They're the same exact numbers, zooming out right here a little bit, that we had for our returns. 309, 305.6, 301.28, they're all the same things. So you might be saying to yourself right now, well, AJ, if that's the case, why did we even bother go and type in all of these formulas that we had? Doesn't seem like a waste of time. We could just use the data analysis tool pack. And you're not terribly wrong in that, but the problem with that is this is purely a trial and error method. If there is a way to ultimately determine from your information what your best alpha is going to be, I don't know how to do it. The best way that I know, and anybody who's taught me how to do this stuff has known, is to set up a spreadsheet in a way that's going to make it really easy for you just to punch in random numbers until you find it by trial and error. So what I did, there's a sleuth eye down here, you see I made a new tab over here. I just put a spot in here where I have a place where I can input a different value to my alpha. I went back to the formulas that we had for y-hat off camera, and instead of just typing in 0.20, I always reference that cell where I'm going to mess around with my alpha. And all of the other stuff that we put in used all of the formulas that we had to determine our mean square error, mean absolute deviation, and mean absolute percentage error. Well, what happens if I now, with this thing properly set up, change that alpha? Like what happens if I change it from 0.20 to 0.15? How is that going to change my 3 measures of goodness of fit down here? And if I put that in, I see that they all increased. We don't want them to be high. We want them to be low. If I went all the way to like 0.10, they're going even higher this way. We're going in the wrong direction. We want to get these to be as small as possible. So we don't only want 0.2. We want something higher than 0.2. So let's try 0.3. If I put in 0.3, it's going to change all of those numbers. So now they got a little bit smaller. Can we get lower? What happens if I go to 0.4? Even lower right now. Our mean absolute percentage error is now down into the 3s. Our MAD, if you will, is down into the 11s. We're getting smaller. Can I go any smaller if I try, like, say, 0.5? And here, how's this going to change our 3 measures of goodness of fit? Well, they all went down again. Now we're well into the 3s for the MAPE. We're almost out of the 11s for the MAD, and our mean squared error is down to 175. What happens when I go to 0.6? Well, this one was okay, but we started going the wrong direction over here. What about 0.7? Now we're really going in the wrong direction. All of our measures of goodness of fit are going down. So I'm thinking that the best number, since 0.5 was the tightest thing that we had, and 0.6 was close, but it went up a little bit. It's probably somewhere right between 0.5 and 0.6. What if I put in 0.55? And that's the lowest numbers that I've seen so far. Now our mean square error is below 175. Our MAD is really close to being out of the 11s, and our MAPE at 3.69 is the lowest that I've seen so far. So if I'm going to use the exponential smoothing model based upon past information, little trial and error right there told me that I don't want to set the alpha to 0.2. Sure, that's what other businesses are doing for theirs. We want ours to 0.55. And as a reminder, when alpha is 0, you're factoring in everything equally. When alpha is 1, you're putting all of the weight on your most recent things. For us, we want to be closer to that 1. The reason being in this case is because it's just a much better predictor of what we're going to need in the next few upcoming days. So we could have a model set up that predicts for the next week upcoming. We'd want to put emphasis on what happened last week, way more than what we had in past days. We are a retailer. We're assuming that our summer months are going to be some of our busier months in this case, because it looks like our sales are going up a little bit during the period. We should put more emphasis on the last few days that we had.